Hello guys, once again welcome to my other presentation on calculating backwards. My name is Muhammad Adam. I am a captain on the Q400 aircraft, and all my presentations are aimed at what we do in the flight deck, as in planning for our flights and doing some practical calculations that don't involve a lot of mathematics, yet they give you certain ballpark figures on many valuable information that a pilot needs in order to conduct a flight. So let's get started once again with all the presentations that follow, and I'll be talking you through them. And if you haven't watched my earlier presentation on the significance of calculating different weights, please do so as well, and do consider subscribing to this channel. I'll be producing more videos as I learn myself the various techniques and the like. And as I keep saying that this platform has got many other nice presentations from various other pilots. Everybody has got their own ways of doing the same thing, and it's all up to the audience to take in what suits them the best. So let's get started, and let's go to our first slide and subsequent slides. Okay, so we will be discussing in this presentation some examples where you are required to make plan in advance. And when you want to plan anything in advance, you work backwards. So you put yourself where you should be, and then you work towards where you are in order to achieve the desired result where you want to be. A simple example in everyday life is, for example, you want to reach an appointment at 7 o'clock sharp, but you will not depart from where you are staying at 7 o'clock. You will depart earlier on, so you're calculating backwards so that you achieve the goal of your time where you are expected to be at that particular time. The examples in flying, a few of them which I just want to talk about, are top of descent calculation, requirement to land at or below the maximum landing weight, and this one you will have to see my presentation on calculation of significant weights on this same platform. Another one is how much fuel should you have on landing at destination. How high should you be from a published waypoint ahead? Weather avoidance, and then there is ILS glide stop capture on short approaches. The last two don't require much calculation, but as you'll see, I'll talk you through it, and we will then go through some examples as always, just to show you how practical we can be in doing these calculations. So let's move on to our first point here, which is top of descent calculations. Top of descent is a point where you want to start to descend so that you reach a particular altitude, whether it's circuit pattern or the altitude at a final approach fix, and you use the very famous 3-to-1 rule, which all of you as pilots know about. You've learned it in your studies, and we still use this today, and I'm pretty sure that for mental calculations we'll be using it for as long as aviation exists. So what you want to do is that you want to end up at your destination airfield where the elevation is X. For example, let's say the elevation is 3,000 feet. You are at an altitude Y. Let's say, for example, you are at 18,000 feet. I'm just giving you some numbers here. Your speed is V, and you need to slow down to U. So this is like an indicated airspeed. Let's say you are doing 250 knots, and you want to slow down to 200 knots, which could be an ideal setting for configuration of flaps and the like. And then you have a headwind or a tailwind of W knots. So how do you quickly work out your top of descent point. In this example, let's say, for example, those of us who are using next generation aircraft like the Q400 I fly, and then there is all other aircrafts like the Boeing 737 NG, which I also flew as a first officer, and others. Let's say you lose your FMS and your magenta track that is very famous on such a setup is gone. So how do you know when to start your descent? Okay, there is this method here using altitude, but I'll also give you one which has to do with the time. And all these you can use as your tools to calculate, okay, when I reach this distance from this waypoint, or when I clock this hours and minutes on my stopwatch or my clock, I shall commence my descent. So the formula is top of descent is equal to 3 multiplied by the difference in your altitude, plus you want to slow down from your speed of, let's say, 250 to 200, which is 50, divide by 10, which is going to give you 5, and plus or minus the headwind or tailwind, divide by 10 as well. So if it's a headwind, you will have to delay your descent, so you go further. If it's a tailwind, because you are being pushed, you'll have to start your descent earlier. So which means that if it's a headwind, you will subtract, and if it's a tailwind, you will add to what you get on the first two entries. Okay, so this will be shown to you as an example. I'm just talking you through this, but I will definitely give you some examples. I hope that makes sense for now. You may give yourself some numbers and give it a go and see if you understand it. It's just very simple formula. Moving on now to the next slide, which is requirement to land at the maximum landing weight. The requirement to land is a concept that I've explained in my presentation on calculation of significant weights. And I mentioned a few things there about limitations and respecting structural values, structural limitations. I would like you to visit that presentation for a bit more in depth, but in this case, you will be familiar with RTOW, which I've explained on that presentation as well. And simply what you do is that if you want to land at a particular weight, you've got to add the fuel you'll burn. So you're working backwards again. You want to land at a certain weight at your destination, but then you want to work out how much fuel, how much trip fuel you will burn. And your trip fuel is a scheduled value according to the computerized flight plans that you get. So this will give you a takeoff weight, which is called regulated takeoff weight. And when you subtract from it the trip fuel, you'll get the maximum landing weight. So the idea is how much should I take off with in order to land at that much, if you see what I'm saying. That is basically the question you ask yourself. So it's always putting yourself where you want to be and working out what you should have and how you should be where you are starting. I hope that makes sense. Let's move on now to the other presentation, other slide on how much fuel should I have on landing. If you are to be told by your operations department that please plan to land with an X amount of fuel at our base station, how would you work out how much you should uplift where you've landed? So let's say airport C is your base. You are at airport B, which is your departure point. So in simple terms, you just have to know how much you will burn between B and C, okay? And then you add to this the amount that you want to land with at your base, which is X, and all this tells you how much you should put in your tanks, which is called the uplift. So burn off is basically the fuel you use between the two airports, which is just like another name for trip fuel. So in here, on this slide, I think it's pretty much simple and self-explanatory. And now we are going to move on to the other slide, which is how high should you be from a published waypoint ahead in descent. Let's move on, and as I keep saying, that examples will be following once we finish explaining all these presentations. Often we make our own waypoints. For example, we modify the routing for short approaches into an airfield. These are for RNAV purposes. It's a very detailed and interesting concept, RNAV, area navigation. And on your FMS, it's that FMS, depending on any aircraft, it's such a brilliant piece of engineering and computerization that you can actually modify published approaches that are in the database as per, let's say, Jefferson and the like, and you can create your own waypoints. So you're coming into an airport, okay, and you have a published waypoint. What I mean by that is that something which is charted, it's on the approach plate of that airport, an RNAV waypoint. Now you want to set yourself up to another waypoint of your choice, which we call A. This is your own waypoint, which you will name it according to the way you want it, okay? And then now you want to know that to continue the descent on the VNAV profile, how high should you be at A so that you give yourself a 3 degrees glide path all the way to B and then down to the landing. Normally done when you are on the downwind leg, then you are going to a waypoint A, and then you're turning base to waypoint B, and then you turn again to your finals. So the distance between them is very important to specify, so let's call it D. Now at B, the published altitude is Y, which is on the chart. you want to know how high you should be before waypoint B, which is at A, and you call that distance, that height rather, x. A formula which I often use is 3d multiplied by 100 plus y. So the 3 is just for a 3-degree glide path. For instance, let's say B is at 6,000 feet on the chart, and you want to create a waypoint 5 miles from this position, which is A. So if you do the mathematics there, you can see that 3 times 5 is 15, add 2 zeros times 100, and then plus the y, which is 6,000. So at A, you should be at 7,500 feet, which you'll enter on your FMS next to your published waypoint. In that case, you'll get a proper 3-degree glide path all the way down to turning base and then to finals. Something very interesting that I keep doing when I do some shortened approaches if needed, and if the controllers allow me to, so I can save fuel and I can also save time. I hope that makes sense. Examples will be following. Let's move on. When we fly into weather, especially for us guys who fly the turboprops, our ceiling is a maximum 25,000 feet on the Q400 to 27,000 feet, but normally 25,000 is what we normally use. We often get a lot of weather. You get very active thunderstorms, and you really get quite severe weather as well, which sometimes can be avoided and sometimes it can't be avoided, and you've got to enter it. You don't have any choice. So what do? Well, in this case, it's just about situational awareness. It's not a calculation. All you do is that you have your displays in front of you. You've got your multifunction display, which is painting the weather radar images in the different color codings that you are aware of. So if you are at night, you can only rely on that display of yours, and well before you even approach it, you just steer using heading select left or right, or you can descend or climb if you're at a lower level. Remember, you cannot climb more than your service ceiling of 25,000 feet, for example. So these things are to do with anticipation and planning ahead. So you're still working backwards, so that when you reach near the weather development, like cumulonimbus cloud and the like, at least you have separated yourself. 20 nautical miles is the maximum separation distance that you can get, but, or rather, you should avoid weather by 20 nautical miles, but people have gone to hundreds of miles just to avoid and being in the clear. So you are effectively working backwards by planning what to have when you near the weather, as I've just said in the second point. I hope this makes a bit of sense, but it's also a bit about common sense as well. Moving on. Sometimes when we approach an airfield or an airport, if it's not too busy and if a radar allows you to do what you call self-positioning on an ILS approach, you may or you can do a shorten approach. When you do short approaches like these, things happen very quickly, so you've got to be always ahead of the aircraft. I can say this now, but when anybody starts, everybody is thrown back, because many things are happening very quickly, and to catch up with the aircraft when you are beginning or starting such procedures, it often sounds very overwhelming. This is a human nature, so don't worry about it. It has taken also me some time to get my fingers pressing the right buttons and my eyes to see the right things, because you are seeing many things at once, you are pressing many things at once. At the same time, the aircraft is moving, coming towards the ground. Lots of things are happening, but as we know, the human mind, when you keep doing something, when you keep practicing it, it becomes second nature, and your mind programs to get adapted to such scenarios. So when you do such things in busy airspace, initially, if you are starting these things, it'll be very overwhelming. You are able to do a proper published procedure as per the FMS, but if you want to maintain your proficiency and increase your situational awareness skills, it is recommended you do such approaches if you are allowed to and you're not breaking any limitations and any restrictions of the airspace. And always you have to ask before you shoot such approaches, so that your proficiency is maintained, you are multitasking, and it becomes very interesting when you continue doing it and you know that, okay, I know what to do next. So this is my advice for you. These are non-standard procedures, but if you're allowed to in good weather, and if radar allows you to do such approaches, traffic permitting, and all other restrictions have been satisfied, then it is recommended that once in a while you try such approaches. So sometimes we want to intercept the glide slope from inside the final approach fix. Okay, so when that happens, you are going to come high. We don't have any calculation on this. It's just about anticipating. And these words, I'm using them now, but when they were being used when I was doing such things initially, I didn't understand anything until I kept on doing and doing and doing these approaches. And by and by, the experience came and you become more flexible. And there you go. You can shoot these approaches. So it's all about time. So don't be impatient. Just continue practicing them, and you'll be getting there, and you'll be able to control all those small bits and pieces to complete the approach. So initially, what you do when you clear for the approach, you set the intercept altitude, the platform altitude you call it, for the ILS, which is on the chart. Now, as you're coming on the center line, you are looking at your distance from the final approach fix. Then your radio altimeter will say 1000 feet to level, or it's going to give you the beep sound in many aircrafts, that is one to level. From there, you look at your position and see, okay, if I maintain the platform altitude, I may come high. I will level off at a higher than required altitude. So if you are very close, just set a lower altitude. So the aircraft keeps descending, so you don't level off. Okay, you can set a low altitude like the minimums of the ILS. And that's what basically you can set. At 1000 feet to level, if you are at a suitable distance from the final approach fix, you can maintain that altitude all the way until you intercept. So these type of procedures and maneuvers need practice, and when you picture them, they become more sensible. And it's fun when you can do them, but always respect limitations, restrictions, and always ask ATC that you'd like to do these approaches. Let's move on.